We're moving on with our course on artificial intelligence. Today, we want to zoom more into agents. We have to understand agents, define them, understand the environments in which they operate. So, previously, we emphasized on rationality. So, it is this concept of rationality that it can be applied in building successful agents. Or, for example, agents that behave rationally or behave correctly. We can also use the concept to build intelligent systems. But also this concept can be made to suit any environment which we might want implemented by be it a robot or a computer system. So a rational agent, just re-emphasizing it as we mentioned it before, it behaves as well as possible, but there are certain determinants how it will behave well. For example, the nature of the environment can also determine how well the agent can perform. But there are different kind of agents that operates in different environments, and as far as the environments are concerned, they are more complex environments. For example, the environment of an operation of a medical field in a medical field can be more complex than a simple environment of a vacuum cleaner in a particular floor or room. So what is an agent? As we just said before, but now want to look at a deeper definition. An agent is anything that can be viewed as perceiving its environment through sensors and catching up and acting upon the environment through actuators. For example, if we're talking about the human being as an agent, we can talk about the eyes, the ears as sensors, then the legs, mouth, voice box, and hands as the actuators. So a robotic agent now might have cameras and infrared rangefinders as sensors, just like as I said about the human being, and it can have various motors for actuators. The actuators are the ones that enable to move and doing actions within the environment. Whereas a software agent, it can receive keystrokes, file contents, and network packets as sensory inputs, and act on the environment by displaying on the screen, writing files, editing files, whichever way, and sending network packets. So how it views the environment, we use the term percept or perceive. So this term refers to the agent's perceptual inputs at any given instant. That is what it sees inputting into the system at any given instant, and over a sequence or inputs over a particular stretch of time. We can refer it as the history of everything the agent have perceived. So it is on this history that we define the agent's choices. That is, an action at any given instant can depend on the entire perceived sequence observed to date. So we can input code actions to do according to a particular perception, but note that the agent here at this level, it's a situation where the agent will only respond to what it have perceived, but not to anything it hasn't what perceived. There is a diagram here which is illustrating simply how an agent communicates with the environment. Yes, the environment, and this is the agent. The sensors are the one that perceives, and input is it just came and it processed by the question mark is like a program, an agent program. We just talk about it in a short while. Then the actuators are the ones that are able to. These actuators are the ones that are able to do actions in the environment. So speaking mathematically, we can say that an agent's behavior is described by the agent function. that maps given percept sequence to an action. There will be a function which in this case we're calling the agent function. It maps the given percept to a particular action. So you can imagine tabulating the agent function that describes any given agent. For most agents, this will be very large table. If we would try to come up with a big function describing every agent, we can come up with an infinite. So we need to put a bound or a length of percept sequences we want to consider. So it's like we're just limiting where we want to focus on. So an extra characterization of the agent can be shown in form of an external characterization of the agent can be shown in form of a table, like we're trying to show or the character or what it does in form of a table. It is that table that we then consider when implementing the agent function. So internally, the agent function or an artificial agent will be implemented by an agent program. So this agent program is the one who will say I'm an expert in artificial intelligence should be able to design and implement. The agent function is an abstract mathematical description, whilst the agent program is a concrete implementation running within some physical system. For example, you can, when we talk about the agent program, you can put it on some chips which you can program, maybe whichever way, Arduino, whichever means which you implement to run the program. So a simple example, without taking much time, is an example of a vacuum cleaner. We can define its world. It's so simple that we can define everything that can happen in its world. This particular world, for example, we can have the one with two locations, square A and square B. The vacuum agent perceives which square it is in first and whether there is dirt in the square. So what does it do? There are certain things which it can do, like it can choose to move left, it can choose to move right, it can suck up the dirt, or it can do nothing, depending on what is being perceived. So one very simple agent function is that if the current square is dirty, then suck the dirty. Otherwise, move to the next square. If the next square is dirty, suck. Otherwise, something like that. So a simple table here can be used to tabulate the agent function. For example, if square A clean, A comma clean in those angular brackets is simply saying square A clean, then the action at the other side it means the agent move right. Then in case A is dirty, if the percept sequence is dirty in section A, then suck the dirt like that. If B is clean, then move left. If B is dirty, suck. We can come up with many ways of defining the percept sequence so that the agent will perform in an intelligent way, or in a right way, as far as rationality is concerned. So what is the right way to fill out the table? We have to learn more as we get more experienced in the course, and also what makes a good or a bad agent, what can make one particular agent intelligent or stupid. All this will be further answered in as we get a deeper understanding of the course. So I advise one to be more exploratory and read as further as they can to grasp much concepts. Let's meet in the next class. Thank you.